Thank you, Peter. I'm actually based here in Toowoomba, not Brisbane. Yeah, we do have a CSIRO site here in Toowoomba.
Sorry.
That's right. Okay. All right, today I'm talking about the newest generation of APSIM, the new version that some people are starting to use, but we're trying to, this is a bit of a sales job in some way. I'm trying to encourage you all to consider using it. But before I do, press the right button, I need to talk about the ownership of APSIM. So APSIM's not owned by CSIRO, which is the organisation I work for. It's actually owned by the APSIM Initiative, which is an unincorporated joint venture between the 6 organisations listed there. Some of them are in New Zealand, Ag Research and Plant and Food Research are in New Zealand, and Iowa State University is obviously in the US. The APSIM Initiative was established in 2007 to oversee all the science and the software development of APSIM, and it's largely to encourage others to participate, but also to contribute to APSIM's development. We have quite a sophisticated peer review process for all improvements to APSIM, and it's, you know, to enable that, it's open source, what I call an open source, which encourages sort of open collaboration. So there's a very large community around APSIM as well as APSIM Next Generation. It's free for non-commercial use, so it's for R&D and education, it's free. If you want to use it in a commercial setting, there is a click wrap, very simple click wrap type arrangements where you can get a commercial license to APSIM quite easily. So is that counting down or up? It's going up, right. I've got a couple of slides on the old APSIM, just to sort of contrast how it's different to the new one. I'll zip through these pretty quickly. So APSIM 710 is the last version of the old APSIM. There'll never be an APSIM 711 or an APSIM 8. APSIM's a farming system is a farming system model for those that don't know it. It models essentially most things that happen on a farm. It's a daily time step model, which means that each day APSIM grows a little bit more biomass, a bit more root, takes up a bit more water and nutrients, and it does it every day. It's a daily time step, and it's a point-based model. So it simulates a point in space, so in a particular paddock or a part of a paddock. But having said that, it can do multiple points and have interactions between those points, and you can script that sort of thing quite easily so that you can then model whole farms. Work commenced on APSIM in early 1990s, so it's been around for a very long time now. And it has a whole range of plant models and soil models. It contains all the major crops that you need in Australia, but also overseas. I'm not going to go through all of those. It gives equal emphasis to the below ground dimensions of the farming system, so it's not just about the plants. It simulates different soil carbon pools in the soil, uptake of nutrients and water. And there's also a livestock component so that you can have grazing. Sheep and cattle can come and go across paddocks. They can eat the plants, and you can model that sort of interaction as well. APSIM's impact is immense. It's used everywhere by predominantly scientists and students all over the world. Many projects over many years. You just need to look at the literature. There's APSIM papers everywhere. Brian Keating gave a good screen of metrics yesterday showing the impact in the literature. It's also used indirectly by more than about 2,000 farmers in Australia through products like Yield Profit and Production Wise. So typically their consultants will use Yield Profit, and APSIM's the engine behind those sorts of tools. So there's an indirect impact with farmers. It's also the engine behind Graincast and some other apps that CSIRO and other organisations produce. And I think we have about 5 or 6 commercial licenses where companies are starting to use APSIM in their consulting business or breeding enterprise. A map of downloads of APSIM. So this is still general APSIM at this point. Predominantly, well, you can see Australia, China, India, US, and Brazil emerging. It usually follows when we travel to these parts of the world that there's an uptake in downloads of APSIM, but that was Brazil anyway. But having said all of that, the old APSIM 710 does have its issues. If you've used 710, you probably know about most of these. Internally, it's very large source code base. There's over 2 million lines of code, which is just a maintenance burden. Very hard to get funding these days to actually maintain and keep the wheels turning. It is slow. If you've ever used it, you know that. Slow run times. A lot of our models don't have validations anymore, so we don't actually know whether some of the, particularly the minor models in 710 actually work anymore. So we wanted to improve that. It's written in 7 or 8 different computer languages, which makes it almost impossible to debug and fix things. Like all models, the documentation is poor. And it's because of the way it's been structured, it just doesn't run behind on cloud compute easily or behind web pages or on mobile apps. It was designed in a time before there was an internet, which is pretty amazing. So in 2014, we decided it was time to start again. So produce a more modern code base. It's described in that paper, that 2018 paper in Environmental Modelling and Software. The conceptual representation of a simulation in NextGen really isn't that different to Classic, to APSIM 710. We use the word APSIM Classic, by the way, to refer to the older one. I probably should say 710. Anyway. So multiple fields, multiple paddocks is still possible. Each of those paddocks, you can have various models that interact, but there can also be interactions across fields. So the top level farm management can be scripted to do different things in different paddocks. So you can have livestock coming and going from different points, different paddocks. You can also make decisions about what you want to sow on in each paddock. So it's quite, wouldn't say easy, but it's straightforward to do whole farm modelling in NextGen much more easily than in 710, in NextGen rather than 710. It's cross-platform. The user interface and the model runs seamlessly on Windows, Linux, and Macintosh. 710 can't do that. Oops, and I pressed the button too many times. It's easier to maintain because we're in a single code base now. We can actually debug APSIM for the first time in, well, forever. It's about 10 times quicker to run. So typically APSIM 710 would take about 40 seconds to run 100 years, historical run. NextGen can do that in about 4 seconds, 4 or 5 seconds, so it's much quicker. But of course, increasing improving the runtime speed just means that our users come up with more complex problems and they need to run more simulations. So it's a bit of a catch-22. Much easier to run on cloud compute, much easier. We have built-in support for being able to describe experiments and treatments and factors. So if you're trying to simulate a real-world experiment, that's much easier in NextGen. So rather than creating separate simulations for all of your treatments, you can describe the simulation once and say, okay, my treatments are sowing by variety, and it'll go and create the simulations on the fly and then run them. And we have some built-in parameter sensitivity tools, namely Morris and Sobol, that some people are playing with. NextGen features a much better way of building plant models. So we needed to try and find a way to let our users build plant models without having to be programmers, essentially. So plant models are described by drag and drop in the user interface rather than writing code. No programming skills typically required to build a plant model in NextGen. It still requires knowledge of how APSIM simulates the various processes. So, you know, it's not completely easy, but at least you don't need to be a programmer. So people like Julie and Lily, you know, use this to don't know why Neil Huth's laughing, use this to build a canola model. Neil uses it to build models as well, and we have a postdoc, Heather, who might be in the room, down the back there, use this to build a mung bean model. So it still takes time though. You know, we often say that, you know, to build a plant model, half that time is just collecting your data, getting it into a form that suits APSIM, understanding the data set before you even start configuring and calibrating a model. So it's not quick, but it's better than it was. We've tried to improve the documentation in NextGen by automatically generating it as much as possible. So when we release a new model in NextGen, we create a whole bunch of simulations of field experiments and then compare predicted versus observed type plots. So that sort of information is then collected by this auto documentation tool, along with description of the model from the source code using a reflection. And we generate PDFs that look something like that. So roughly like a journal paper, but not really. But it's still, by auto-generating it, the advantage is that it's you know, much more likely to be up to date. That was one of the issues we're trying to solve from 7.10. All models are tested continuously in NextGen. So we go to a great deal of trouble to prove that our models work. And so there's a peer review process that they have to go through, where our reference panel examine all new models, and they specifically look for evidence that the model works. And that's usually in the form of validation graphs or sensibility tests or both. And so we collect those. And so we generate these sorts of stats. So every time a file is changed in APSIM, even if it's not plant related, any file, so I could be fixing a bug in soil water, say, what happens is that the system will automatically recompile APSIM. We then run through the, 4, 5, 6, 7,000 test simulations, and we look for evidence of change. And sometimes you expect change if you're improving the phenology of the wheat model, but sometimes you don't. And so we collect these sorts of stats on the right here. So the number in brackets is the accepted value of the RMSE or whatever the stat is. And so if we then go and change something and we get a different number, then we get a little red cross, meaning that that statistic has not improved. A green tick means that the statistic has improved. So you end up with lots of these sorts of things. And then, you know, it's then up to the decision of the person who made the change to say yes or no, whether they expected that, and whether we then approve those new changes, and those stats then become the newer accepted ones. That's the current list. This is the list that everyone always asks for in NextGen. That's the current list of plant models and other models that is in NextGen. So we don't have all the models ported from APSIM 7.10, and we probably never will. It's done on a on-demand type thing. So we do the important ones first, and we do other ones when people give us funding to build something. So there's some oddball ones there, like oil palm. Neil had an oil palm project that he was written into, and one of the milestones of that was to build an oil palm model. So that's usually, well, typically how it happens. Down to the last 2 or 3 slides. I was going to do a completely data-free presentation, but at the last minute I put in 2 graphs. It's not really data, I guess. This is just a simple graph of downloads of APSIM on the left and NextGen on the right. So you can see roughly when NextGen came into being in about 2016, there's a real uptake of APSIM NextGen in the last few years, and less so in APSIM overall. Interesting thing is I always point out there's a little blip here where our server went down over the Christmas break. So there's a flat bit, but generally, even over Christmas, people still keep on downloading APSIM, which I always find amazing and sad. Yep, last slide. Should you use APSIM NextGen? Well, yes. I'm a salesman. It's being used in many projects. I haven't used APSIM 710 in, well, 4 or 5 years now, and almost no development is going into improving APSIM 710 at all. So if NextGen has the models that you need in your project work, then absolutely give it a go. Yeah, you know you need it, so go and get it. Thank you.